In our last section, we solved this type of equation when we were given that 1 was a zero of the function. So remember, our steps were to use synthetic division with the number given, then we're going to factor, and then we're going to solve it. So looking at this function, this polynomial equation, I have a 1x cubed, a negative 2x squared, a negative 11, and a 12. And I'm going to use synthetic division with the number 1. And the reason I use the number 1 is 1 is given to me right here. That's what I'm going to use. Remember, with synthetic division, you bring your first digit down, and then you multiply. 1 times 1 is 1. I add this up, and I get a negative 1. Multiply, 1 times negative 1 is a negative 1. I add this group up, and I get a negative 12. 1 times negative 12 is negative 12. I add this up, and I get 0. My problem began with x cubed, so that means that this answer right here begins with x squared. So that would be 1x squared minus 1x minus 12, with a remainder of 0. So what I can do next is I can take x squared minus x minus 12, and I can factor it. The factors of 12 that subtract to give me 1 are 4 and 3. Then I factor it. So after I factor it, my last step is to set those factors equal to 0. Set x minus 4 equal to 0, set x plus 3 equal to 0. So when I solve this one out, I get x equals 4, positive 4. And when I solve this one out, I get that x equals negative 3. So this particular equation has 3 answers. 1 is an answer, 4 is an answer, and negative 3 is an answer. So those are the zeros of the function. Now, in our next example, we need to know what happens if we don't have this hint right here. So if I just asked you, please solve this equation, and you don't know where to start, that's what our next example leads into be. And so that's what I say right here. So what we're going to do, if that extra 0 is not given as a hint, we're going to use something called the rational zero theorem. And this theorem is found in your textbook. The way that you find your possible zeros, you take factors of the constant and you put it over factors of the leading coefficient. And this gives you what I call a list of candidates, kind of like an election. It gives you a list of people who would be qualified to qualify as a zero of the function. Now you'll notice for these two pieces, I ask you possible. When I ask you possible, all you do is make a list and stop. For the keyword possible, make a list and stop. That's it. So again, possible, you think of like candidates for an election. That may not be who wins the election, that's just who qualifies. And that's what I want you to do here. Just give me a list of qualified applicants. On the previous slide, remember it told you that your possible zeros could be found by taking your factors of your constant. Okay, and the constant is this number right here. And putting that over the factors of the leading coefficient. Okay, so let's make this list out. My constant is the number negative 10. So if we think about the numbers that go into negative 10, we could take a positive 1 and a negative 10, but we could also take a positive 10 and a negative 1. So for this reason, you want to list both positive and negative factors. So 1 and 10 go into 10, and also 2 and 5. Those numbers go on the top because a constant goes on the top. The leading coefficient is that 2 in front with the pink arrow. So that would be 1 and 2. Those are the numbers that go into 2. So what you're going to do after that is make a list. I have to put all of the numbers over 1. So you would say 1 over 1 and 2 over 1, just going across the top, everything over 1, and 5 over 1 and 10 over 1. And you put all 4 of those numbers over 1. So then you can go back and put all of the numbers over 2. So you could say 1 over 2, 2 over 2, well that's 1, that's already in the list, 5 over 2, and 10 over 2 is 5, and that's already in the list. So this list of blue possibilities, those are our possible zeros for this function. Okay, so let's try another one. Again, remember it said make a list and stop. This blue answer that you see here, that's what I'm looking for with a possible list. Okay, so let's try the next one. Remember your factors of your constant for this one are going to be all of the factors of 14. So the factors of 14 are 1 and 2 and 7 and 14. Okay, this is my constant. That's where I'm getting those numbers. The factors of 3, that's your leading coefficient. That goes on the bottom. So what you need to do is make a list out of this group. Put all of the numbers over 1. So you could say that's 1 over 1 and 2 over 1 and 7 over 1 and 14 over 1. And then you're going to put all of the numbers over 3. So that would be 1 over 3, 2 over 3, 7 over 3, and 14 over 3. Now as far as zeros of a function go, those are the only ones that are possible. So for example, 5 would not solve this equation. -9 would not solve this equation. Regular 3 would not solve this equation if it was set to 0.